Okay, so in this section, we're going to learn how to factor. And again, one of the things you have to find is a GCF. All right, now let's kind of talk about the idea of GCF, and then we'll go through this little part here. We'll kind of review this little part. So let's talk about the GCF. In a previous worksheet, you were asked to do this. You're asked to multiply. And let's say you want to multiply this, 4 times 3x minus 5. Okay, so 4 times 3x minus 5. That was one of the worksheets you had to turn in Thursday. How would you multiply this? What would you do to multiply these things? Distribute. Now, okay, now let me ask you this. If I look at the number 8, and I write 8 as 4 times 2, that's a true statement, right? Okay, so I wrote 8 as 4 times 2. I wrote 8 as a product of two things. One of them's a 4 and the other one's a what? 2. Those two things, the product of those two things are called factors. So these are called factors. So remember, this whole chapter deals with factoring. So the idea of factoring is to write as a product. So 4 is a factor, and what else is a factor of 8? 2. I could have written 8 as 1 times 8. 1's a factor. In fact, 1's a factor of every number, every term. And what else is a factor? 8. So these are factors. You understand what I mean by factors? Okay? So if I look at this right here, this product, and I'm multiplying how many things? 2. Okay, 2. 4. When I read this, I say 4 times what? What's in parentheses? 3x minus 5. That's how you read it. You don't say 4. You don't read this as 4 times 3. You read it as 4 times what? 3x minus 5. That's how you read this. So in terms of factors, 4 is a factor, and so is 3x minus 5. Because those are the two things that are being multiplied together. 4 and what? 3x minus 5. So those are your factors. On another worksheet, you had this. You had 3x minus 2 times 3x plus 6, let's say. I made that up. Let me do 5 times 3x plus 5. To multiply this out, you have to use what method? FOIL. You could have also used distributive property as well. But most students, when they see that they're multiplying two binomials, they'll use the FOIL method. But if you look at this, I am multiplying how many binomials? 2. So in terms of factor, remember factors is a product. It's part of a product. So how many things are being multiplied together here? 2. What's one factor? 3x minus 2. What's the other factor? 3x plus 5. So those are your factors. So your factors are the things that are being multiplied together. So 3x minus 2. And the other one is 3x plus 5. So you have to understand what factors are before you can factor. All right, now on the previous worksheet, when I multiplied this, what did I end up with? 12x minus 20? Okay. So what's going to happen now is this. You will start out with the polynomial, and the direction will say to factor. And then you're going to go backwards. So you go from here to here. That's what you're going to end up doing now. So it's a reverse of what you used to. All right. So factoring means you get this polynomial and you rise a product. That's all it means. Okay? Now, let me ask you this. You see this right here? If I write this 2 times 6x minus 10 right here, and I distribute, isn't that still this right here?
Mm-hmm.
Yes. Okay? So I factored this as this. Okay? So some of you may say, well, which one's correct? Do I factor it as this or do I factor it as this? Nope. When you factor, you're always going to look for the GCF first. So GCF means what? Greatest common factor. Okay? So in the directions, when it says factor, you have to use the greatest common factor. Not just any common factor, but the what? The greatest common factor. All right, so I'm going to go back to this polynomial right here. How many terms, now I'm using terms. How many terms do you see? 2. Your first term is what? 12x. Your second term is a negative 20. All right. So if we think of, just look at the 12 and then the 20. What is the largest common factor? What is the greatest common factor of 12 and 20? 4. 4. Not 2. 2 is a common factor, right?
Mm-hmm.
Does 2 go into 12?
Mm-hmm.
Does 2 go into 20?
Mm-hmm.
Yes. 1's a common factor because 1 goes in everything. Does 1 go into 12? Does 1 go into 20? Yes. But what's the largest common factor? 4, and that's the one I use. The greatest common factor. So the first step is to always look to see if you have a GCF. Other than 1, because 1 goes into everything. So other than 1, is there greatest common factor? 4. So then what you're going to do is you're going to write it like this. Now listen carefully. So when you factor means, just think of generalized, factor means to rise a product. So you're going to rewrite this as a product. One of your factors has to be your GCF. So what's your GCF? 4. So 4 times, in parentheses, whatever you need to put in there to get this back. Think of the distributive property. 4 times what is 12x? 3x. You agree?
Mm-hmm.
Minus 4 times what is 20? 5. So there's your answer. 4 times 3x minus 5. Okay? All right. So put this right here as number 1. So we factor. Number 1 right here. Number 2, suppose you had this. Suppose in number 2 you had 16x minus 32 minus 32. So you want to factor this. So you want to write this as a product. So someone could say this. Someone could say, well, I know I can write this as 2 times 8x minus 16, right? That's a true statement. But that's not what you're going to give me. Although you wrote this as a product, you didn't factor completely. So when we use the word factor, we mean factor completely, meaning that I need for you to use the GCF whenever possible. What's the GCF of these two terms? Not 8. 16. Suppose you said 8 though. And it's possible that you're going to do this. Suppose you said 8. All right, let's think about this. So do y'all agree that it's going to be 8 times, and then what's going to be in parentheses? 8 times what, 16x? 2x. Minus 8 times what is 32? 4. Look at these two things. Do those two things still have something in common? Yeah, what do they have in common? a 2. So 2 times this 8 is what? 16. So if you do make that mistake, you can easily fix it by seeing what you have inside the parentheses. So the GCF is really what? 16. So your answer has to be this. 16 times what? X minus 2. Close the parentheses. And always check yourself. What's 16 times x? 16x. And what's 16 times a negative 2? A negative 32. Okay? I'd put the box to say the answer. But normally I'll have a blank. And in the blank you would say 16 in parentheses, what? X minus 2, close the parentheses.
What chapter is this in?
13.1. 13.1. All right, now, sometimes though, you see how the GCF was easy to find because the numbers were not that difficult to deal with? Sometimes though, it's not that easy to find. So for example, suppose I asked you to find the GCF of these two numbers. Find the GCF of, and let's say I want to find the GCF of let's say 140, 48. Now, some of you can look at this and tell me what you think the GCF is. What do you think it could be? Huh? Now, you see how some of you are like struggling right now with this? So there are two ways you can find the GCF. If you can't see it right away, huh? What'd you say? 20? All right, let's talk about 20. If you say the GCF is 20, remember in the word GCF is the word common, right? Common factor. So 20 better go into both of those. Does 20 go into 48 evenly? No. So it can't be 20. 4. You think 4? You think 4 is going to be the largest? Now 4 goes into 40, 4 goes into 48, right? So that is a common factor, but the question is it the greatest? Okay, well let's see. So there are a couple of things you can do. One way is to list the factors. That's not the most efficient because your numbers could get big and you could miss some of those factors. But let's do that one way first, and then we'll talk about the other way, and that's the way that you're probably going to use if you can't figure it out right away. The first way is to list your common factors. So list the factors. List the factors of each. So 40. So list the factors of 40. For example, 1 goes into every number, right? So 1's a factor. So 1, and 1 times what is 40? 40. So 40 is a factor as well. So I have 1 and 40. So kind of, if you need to, put them together if you have to. What else? What else goes into 40? 5. Okay, 5, but let's think about the next one after 1. 2. 2 and what? 20. All right, someone said 5. 5 and what? 8. 4 and 10. So all those are factors, right? All those are factors because each of those goes into 40 evenly. And I think that's it for that one. Oh, yeah, that's it. All right, now what about 48? 1 and what? 48. 2 and what? 24. Notice I'm separating by commas because I'm listing the factors. The factors are 1, comma, 48, comma, 2, comma, 24. There's some others. 4 and 20. I'm sorry, 4 and 12, right? 6 and what? 8. Am I missing anything else? See how sometimes it's difficult to find all of them? So you could easily miss one.
Eight's the greatest.
So I think I have all of them though. Now notice they have some common factors, right? They have 1 in common. They have 2 in common. They have 4 in common. They have 8 in common.
Eight's the largest.
What else? That's it, right? So remember how someone said 4? What is 4 is a common factor, but is it the largest? No. What's the largest? 8. So the GCF of 40 and 48 is what? 8. So that's your GCF. That is probably not the way you want to go with this. The way you really want to do this, if you can't look at it right away and determine what the GCF is by doing the factor tree. So you may remember factor tree from a couple of semesters ago. So use a factor tree. And basically the factor tree writes the number as a prime factorization. And we talk about a prime factorization, you're basically saying a product of prime numbers. A product of prime numbers. Well, if you're gonna use a factor tree using your product of prime numbers, you first of all better make sure you know what a prime number is. Remember, a prime number is a number whose divisors are 1 in itself, whose only factors are 1 in itself. So for example, 5. Is 5 a prime number? Yes, because the only two numbers that go into 5 evenly are 1 and what? 5. What's the smallest prime number? 1's not a prime number. What's the smallest prime number? 2. 2. In fact, the only even number that's prime is what? 2. What's the next prime number? 3. Then 5. What's the next one after 5? 7. Next one? You're missing one. 9's not a prime because of 3. 9's not prime. 11. Then 13. Then what? 17. We're missing one. 19. 20 is even. The only even number that's prime is what? 2. 21 is not prime because 3 goes into 21, 7 goes into 21, 23, and they're an infinite number. But those are your prime numbers. So prime numbers are numbers whose divisors are 1 in itself. So if we go back to number 40, then, and I want to use the factor tree. So basically you're going to write this as branches. And you find two numbers whose product is 40. Any two numbers. Give me two numbers whose product is 40. 8 and what? No, don't use 1. Because remember, what you want to do is eventually write as a product of the prime numbers. So the question is 1 prime? 8 and 5. And what you want to end up with is the ends of these branches being prime. So when I wrote as 8 and 5, and someone else could have said 4 times 10, does not matter, right? Does not matter. You're eventually going to get the same answer. When I look at this one, though, which one's prime? 5. So I'm going to circle it because that's all I can do with this branch. But for this one, I can write it as what? Or 2 and 4. And 2 is prime, right? And then 4 I can write as what? 2 and 2, and they're primes. So I'm done with that with 40 using to start 5 and 8. Over here, this is going to be what? 2 and 2, those are primes, and this will be 5 and 2, and those are primes, right? So 40, then I can write as a prime factorization. So write as a product of prime numbers, and let's put them in order. So I have how many factors of 2? 3. So you're going to say 2 times 2 times 2 times what? 5. Okay? Now let's do 48. Give me two numbers whose product is 48. 6 and 8, okay. All right, what about 8? 4 and 2. Which one can I circle? The 2. 4 is what? 2 and 2. I can circle those. 6 is what? 3 and 2. I can circle those, right? So am I done with 48? Yes. So 48, in terms of prime factorization, is how many factors of 2? 4. 2 times 2 times 2 times 2 times what? 3. Once you write it in prime factorization form, then all you do is see what they have in common, the sets of factors they have in common. I have a set of 2 here. Do I have another set of 2's? Yes. Do I have another set of 2's? Do I have another set of anything? No. That's all I have. So my GCF will be this set of 2's times this set, which has what factor? 2, times this set, which is 2, and what does that give me? 8. Gives me 8. Now, for right now, I want you to write 40 also. We're going to come back to this in a little while. I want you to write 40, the prime factorization in terms of exponents. So rather than just saying 2 times 2 times 2, I can say 2 to what power? The third, and then times what? 5. And in 48, I can write as 2 to what power? The fourth times what? 3. Okay. So I'm going to use this in a little while. But that's what you do if you're going to use a factor tree. All right, let's look at another with the factor tree. So here's another one with the factor tree. So that's number 2. All right, number 2, suppose we had 60 and 84. 60 and 84. Now, guys, there's probably no way that you could guess at the GCF right away for that one. So let's just use a factor tree. What are the factors of 60? 30 times 2. Okay, I'll go with that. I can circle which one? 2. 30 is what? 2 and 15. Someone else could have said 10 and 3, right? Does not matter, but I can circle which one of those? 2. 15 is what? 3 and 5, 5 and 3. I can circle both. And I'm done with 60, right? So 60 is what prime factorization? Let's put it in order. 2 times 2 times 3 times 5. All right, now let's do 84. Give me two numbers whose product is 84. 6 and 13? 6 and 14? Now, I probably would not have used that one because I would not have used 6. I would have seen that both of these numbers are divisible by what? 4? So I said 4 times 21, but we can use 6. What'd you say? 6 and 14? Is that 84? Okay. Can I circle any of those? No. 6 is what? 3 and 2. I can circle both of those, right? 14 is what? 2 and 7. I can circle both of those. So in terms of 84, what is the prime factorization? 2 times 2 times 3 times 7. Once you do that, then we look for the common factors. So which ones can I circle? The 2. This set of 2s I can circle. What else? This set of 2s I can circle, right? And what else can I circle? The set of 3s. And that's about it. So my GCF will be a factor of a 2, a factor of a 2, and a factor of a 3. So what's my GCF? 12. GCF is 12. Okay? All right, and go ahead and let's write this in terms of exponents. That'll be 60 is 2 to what power? The second times 3 times 5. And 84 is 2 to the second times 3 times 7. All right. Okay, we're going to come back to this in a little while. The exponents, we're going to talk about the exponents again in a little while. Let's do one more. Let's do one with 3 numbers instead of 2. So 3 numbers. So this is number 3. So let's say I had this. I had 44, comma, 64, and 100. 44, 64, and 100. So let's suppose you're not sure what the GCF is. So let's do the factor tree. So which numbers do you want to use for 44? 11 and 4. Okay, 11's prime. I can circle that. 4 I can write as what? 2 and 2. So I'm done with 44. So 44 is 2 times 2 times 11. And let's do 64. Give me 2 numbers as product of 64. 8 and 8, okay. I can't circle those because those are not prime. And remember, they're not prime, it's composite. So those are composite numbers, but we're more into the word prime here. 4 is 2 times, 8 is 2 times 4. 2 I can circle. 4 is 2 times 2, so I can circle those 2's. Now in the next branch, I have 8. I'm going to do it again. That's 2 times 4. Circle the 2, and then 4 is 2 times 2, right? So the only factors left are factors of what number? 2. So 64 is 2 times 2 times 2. So 6 factors, right? So I need 6 factors of 2. All right, now 100. 100 would be, what do you want to try there? 10 times 10, okay. 10 is 5 and 2. 10 again is 5 and 2. So in terms of 100, I have 2 times 2 times 5 times 5, right? All right. So now to find a GCF, I look to see what all 3 numbers have in common, the factors they have in common. Do they have any 2's in common? Yes. So I can group these together. So I have one group. Do I have another group I can do? Yes. And that's it, right? So my GCF would be 2 times 2, which is 4. All right. And, even those 3, remember, greatest common factors is what they have in common, but the largest. So so you see this 2 right here, there's no other 2's to use it with. Okay? All right, now, let's go ahead and write this as an exponent. So 44 is 2 squared times 11. 64 is 2 to what power? 6. And then 100 is 2 squared times 5 squared? Okay. We're going to come back to this in a little while. All right? So that's how you find the GCF with numbers. You use a factor tree. It really is helpful. All right, now let's look at number 4. All right, number 4, suppose I had this. Suppose I had, now listen carefully to this. I'm going to use, I know. Number 4. Suppose I had this. Suppose I had 3 cubed, comma, 3 squared, comma, 3 to the 5th. All right. So I have 3 cubed. So I wrote these as exponents. And the question is this. What do you think the GCF is of those 3 numbers?
How many exponents they have in common?
I'm just asking you to tell me what you think it is. What do you think it is? You see, you're struggling with that, and you shouldn't, because we dealt with this a while ago in all 3 problems. You think the GCF is just 3?
No, it's actually not.
You think the GCF is 3 what? Right as an exponent. She says it's 9, but 9 is 3 what? Squared. So she's saying it's 3 squared. Why isn't it 3 to the 5th? Because in the word greatest common factor is the word greatest, right?
One has to have the same amount.
Okay. So your greatest common factor, remember when we circle these groups? They have to have the same amount of factors, some amount of pairs, so to speak. Okay? So if you look at 3 cubed, isn't 3 cubed 3 times 3 times 3?
Yep.
And isn't 3 squared 3 times 3?
Yep.
And isn't 3 to the 5th 3 times 3 times 3 times 3 times 3?
Yep.
And then when we did all these things, didn't we group the common ones?
Mm-hmm.
Can I group anything else?
No.
No. So 3 times 3 is 9. So that's your GCF. So notice when it's written as an exponent, and notice all the bases are the same, right? Base 3, base 3, base 3. So when it's written as an exponent, the GCF is the one with which exponent? The smallest or the largest? Smallest. Very good. So the GCF is 3 squared, or you can say 9. That's your GCF. So when the exponents are given, when it's written as exponents, you're going to choose which exponent? The smallest. So now that takes us to variables now. Number 5. Number 5, suppose I had y squared, comma, y to the 4th, comma, y to the 5th. All right, think about what we just did.
So y to the square.
Y to what power?
Squared.
The second, y squared. Because I choose the one with the smallest exponent. You understand?
Mm-hmm.
Now, remember though, if you write it out, that really means y times y. And then the next one is y times y how many times? 4. And the next one is y times y how many times? 5. And I group them. So how many factors of y that are grouped? 2. So y times y is y squared. So that's your GCF. All right. So from this, the take is this. The take is that when you have it written as exponents, then the GCF is going to be the one that has the smallest exponent. Smallest exponent. Okay, number 6. Number 6, suppose you had x squared y cubed, comma, x y to the 4th, comma, x to the 4th y squared. So you have those 3 terms. So x squared y cubed, x y to the 4th, and then x to the 4th y squared. All right. So let's start with the x's first. Is there an x in every term?
Yeah.
Yes. So in my GCF, I will have a factor of the x. I just don't know how many yet.
Mm-hmm.
Do I have y's in every term?
Yeah.
Yes. So I need at least one factor of y in my GCF? Question is how many? So let's start with the x. So I have how many factors of x here? How many here? How many here? How many do I need? 1, smallest exponent. So far my GCF is x times, okay, let's do the y's. How many factors of y do you see here? 3. How many here? How many here? How many you need? How many you need? 2, smallest exponent. So there's your GCF, xy squared. Okay, same idea from the previous 2. So you, first of all, it has that variable has to be in every term, and use the one with the smallest exponent. Okay, number 7. Number 7, suppose you had 30 y cubed, comma, 20 y squared. 30 y cubed, comma, 20 y squared. So let's start with the coefficients, 30 and 20. What's the GCF of those? Huh? You're saying 6 goes into 20 evenly? 10. You said 10? Okay. I thought it sounded like 6. But yeah, 10, right? Now, not 5. 5 is a common factor, but it's not the greatest. The greatest is which one? 10. So what's the answer? 10 what? 10y squared. All right. Number 8. All right, number 8, suppose we had 66 xy, comma, 30 x squared y. So 66 xy, and then 30 x squared y. Let's start with the coefficients. What's the GCF of 66 and 30? If you're not sure, what should you do? The factor tree. Yeah, it's 6. So let's do the factor tree. If you wasn't sure, do the factor tree. Nothing wrong with doing the factor tree. So let's do 6 and 30. Let's do those. Because the variables are easy, right? The variables are the easy one. So 66 is 6 times what? 11? So 11 is prime, and 6 is 3 and 2. 3 times 2. So 66 will be 2 times 3 times 11. 30, let's do 10 times 3. So 3 is prime, and 10 is 2 times 5. So 30 is 2 times 3 times 5. So what do I circle? The group of 2's, and I circle the group of 3's. So the GCF would be 2 times 3, which is 6. So that's your GCF. So the GCF of 66 and 30 is 6. So what's the GCF of those two terms, though? 6 what? XY. You all agree? 30 XY. All right, number 9. Okay, number 9, suppose we had this. Number 9. All right, suppose we had 80 x cubed, comma, 30 y, or 30 x squared y. So 80 x cubed, comma, 30 x squared y. Let's see what 80 and 30 first. The coefficients. What's the GCF of 80 and 30? What do you think? 10. 10, right? Okay. And what about your variables? X squared. Okay, I agree with the x's. X squared. What about any y's? Do I need any y's? No. Because your GCF, your variables have to be in all of them, right? Is y in both terms? No. But x is, have 3 factors here, 2 here. I need how many? 2. So your GCF is 10x squared. What about this, number 10? Suppose I had 8m, 12m n, and 3 n. 12m, 8m, 12m n, and 3 n. Let's start with the coefficients. What's the GCF of 8, 12, and 3? Huh? What'd you say? Does 3 go into 8 evenly? No. So it's a GCF 1. GCF of 8, 12, and 3 is 1. So keep that in mind. What about your variables? Is m in every term? No. It's got to be in every term. So in terms of variables, you're not going to use any for your GCF. So what do you think your GCF is? 1. GCF is 1. Okay, GCF is 1. They have nothing in common other than 1. 1's the only common factor they have. And that's the largest. Okay? All right, now